One thing maybe I should have pointed out on the previous videos, I had these return zeros in the get press and get temperature, because if you don't, it's basically giving you a control reaches to the end of a not void function. So I just put in return 0 for now, just so I didn't get any kind of warnings or errors when I was compiling. But of course, you know, we're not going to be returning 0. We're going to be returning the pressure. So now I'm getting ready to read the pressure in. So this one's not going to be too difficult, but it's going to be very similar. It's actually going to be a lot easier than the other one. So let's go back to the data sheet. Actually, the data sheet is right here. I went to YouTube and started uploading videos and killed my data sheet. Okay. So going back to the data sheet, we can see here that the pressure and temperature are 10-bit, and they're unsigned values. So I can use the unsigned integers here. So there's no signed data on them. So I have to get the pressure, I have to read in both the pressure and the temperature data. So I'm going to read both. And of course, you should fill out the function name, description, and usage. Read both PADC and TADC. So the first thing, whenever you're doing a read, we need to set the point. Well, first, actually, the first thing we need to do, I should be careful. The first thing we need to do is run a conversion. Because we actually have to have it take a measurement. So in order to do this, we have to first, again, just like we did on the other one, we have to start it up. But now we're not the MPL115A2, I2C master. Send start. And we need to do the slave address. We need to tell it whether we're going to be writing or reading. Well, we're going to be writing because we're giving it a command. And then we're going to do timeout infinity. So then we're going to actually give it the command to do the conversion. And then I'm actually going to go ahead and stop the I2C bus, because we're going to actually need to restart. It's going to seem a little weird what we're doing here, but this is how we have to do this. Not send start, send stop. Stop. There we go. You put in infinite. So that runs a conversion, but I want to go back to my data sheet here. Not that data sheet. I've got too many data sheets floating around here. Because, where is it here? It's written here several times. I'm just trying to find it again here. It's going to be in some of the data here at the end, I know. Or at the beginning. Operating supply, range resolution, data time, setup clock frequency. Here, let me do a search for convert. Conversion time. 1.6 milliseconds, maximum is 3 milliseconds. So we're going to go ahead and put in our code a delay here of 3 milliseconds. And we're putting that delay in because this is the maximum time for taking a measurement. We want to make sure that the measurements have been done before we read the pressure and temperature in. So now we're going to read the pressure and temperature, but remember, to read the pressure and temperature in correctly, we actually have to first do a write command, because we have to set the pointer to the correct address. Because you think about it, we've just read in coefficients, so that thing's probably pointing at C, and then we ran a command at 12, so it could be pointing at the wrong location. So we need to send another start here and then do another write byte. And this time what we want to do is, well, we're going to read the pressure in first. We're going to read both pressure and temperature in. But let's scroll down and pressure most significant byte, because that's the first one we want to read in. And then we're going to restart and read mode and read the data. Now that we've written this, we say, okay, well, wait, we're going to need some variables here. So these are unsigned ints in this case, from the because there's no signed bit. So I'm going to create a 16-bit integer. Even though they're only 10 bits, I need to create a large enough integer for them to be stored in. 8 bits is not going to be large enough to store it. So I'm going to just do this as p data. I'll initialize it to 0. And then unsigned int 16 t data, and I'll initialize that to 0. And then I'll have an unsigned int that's 8 bits that we're going to just call data, just like we did when we were reading in the coefficients. And now I'm actually going to go back and copy some of this here, because I'm going to go back and copy this A0, because it's almost going to be identical. Because what do I need to do? Well, first I need to restart in the read mode. So I'm restarting in the re mode. Restart, and now I'm not reading the most significant byte of A0, because of where I've put the pointer, it's of pressure. And I'm not going to store it in, of course, A data. I'm going to be storing this in P data. And then I'm going to do the same thing here, and this is going to be P data, and then I'm going to do the OR equals data. Now this isn't done because, remember, this is 10 bytes. So we would have, right now what we have, the way it's written, is this would be P9, P8, dot, 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 P1, P0, and then 1, 2, 3, 4, 5, 6 zeros, because of the way we've read it in. So we need to now do another bit shift so that we put those zeros in the front of the data. So P data is equal to P data. Bit shifted to the left 6 bytes. And so now we're going to be 0, 0, 0, 0, 0, 0, P9, P8, dot, 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 down to P0. All right. So I don't need to restart, because if I look at the data sheet, the next thing it would be pointing at would be the temperature. So I can literally just kind of copy and paste this code and just edit it so that it is correct. You have to be careful when you're editing it to make sure it's correct. So I don't need to do the restart. Read the most significant byte. In this case, it's of temperature. And I actually forgot to change this here, of pressure. So this would be least significant byte of temperature. And then I'll delete these comments out. Don't need those comments really anymore, because it's the exact same thing we're doing. The only thing I have to do is make sure, okay, well, this is temperature data, and temperature data, and this is also temperature data. Now I just have to go to my data sheet, if I can get to the right window here. I keep going to the wrong window, damn it. And scroll down here and find the formula here that we need. And the formula here, that's fine, that's showing an example, but I like the actual formula here. Where's the formula? Here we go. Pressure compensated. So I'm going to have this other variable here, pressure compensated. And so I'm going to create, that's going to be, because these are floats now, so that's going to be a float, pcomp, and I'll initialize that as 0. And then pcomp is equal to, well, it's going to be A0, so underscore A0 coefficient plus parenthesis B1 coefficient plus C12 coefficient times, now I need to make sure I cast this correctly. I need to cast this as a float, my T data. So I'm casting my T data as a float times my P data, which I need to cast as a float as well, plus B2 coefficient times T data, which I need to cast as a float. Okay, and so all I've done is typed in this formula here for us. That's all I've done, is done that formula here. Now let's make sure I actually have it correct here. I think I might be missing a parenthesis. No, I'm not. No, I'm good. I've got all the parentheses I need. All right, so that's to compute the compensated pressure. And now to get the pressure in kilopascals, there's this formula right here. So I will say here a float, and this is actually the pressure, which is equal to 0. So my pressure computation is going to be pressure is equal to, and then I do pcomp, it's already a float so I don't have to cast it, times, well, instead of doing that we could just do, well, what's 115 minus 50? It's 65. So 65.0 divided by 1023.0. Now remember, we do the point zeros so that we keep these as floating point computations and not as integer computations, plus 50.0, because that's, again, just the formula. Now I need to return that value because that's what the function's supposed to do. So now I've gone through and computed the pressure. So let's go back and debug this and see if we can get a reasonable amount of pressure here for this. So my sensor's still connected up, and so what I'm going to do here in my main C program here, I'm going to do inside this for loop, I'm going to say, well, I'm going to define my float up here. So I'm going to say float, I'll just call it press for pressure. And I'm going to say press is equal to MPL115A2 get press. And then in order for it to have that being a used variable, I'm going to say if press equals 0, I'm going to just return 0. Because this is the main function is not a void function, so I do get to return a value. That basically would just kill the program. It would just stop running if the pressure is equal to 0. Now, we won't necessarily be able to tell that, but it makes it so that when we debug this, we can actually see that the pressure is actually changing here, or see what the pressure is. So I'm going to go ahead and run it in debug mode again. And what I'm going to do is I'm going to go to my MPL11 and okay, we took all those breakpoints off, good. I'm going to go and put a breakpoint here right at the T data here, at the very last one, and see if we get all the way to there. All right, something's going on here because I'm not getting there. So let's see what's going on here. Let's stop this. Well, one thing I already know that I forgot to do is I forgot to stop the I2C bus, but that's not going to be causing us the issue here. So let me go ahead though and stop the I2C bus. Man, I really cannot type this today. I hit caps lock now. So let me send the stop there. And let me go ahead and put a breakpoint up here and run this command again here. See where I might be hanging up. Okay, so I'm in the get pressure here, so I'm going to do it kind of a step over to see which ones, because I'm hanging up somewhere. Okay, delay 3 seconds. Send start. Okay, write the master byte. Send restart. Okay, so it looks like it's not reading in any data here. Well, I can see something I did right here that's wrong. That should not be there. And so what we're going to do here is I'm going to show you how you can debug a little bit more. So I'm going to do a volatile here, and I'm just going to do a volatile int flag equals 0. And what we're going to do here is we can see here, we're going to put a bunch of flag equals here on these lines here, because all of these things actually return commands, like return values here. And those flags can tell us information on what's going on here, on why it's not working properly. And this should actually be, because that's the last byte of data, that should be a NAC data anyway. All right, so I've got a bunch of flags there, so I'm going to start my debug mode up again. It's saying it's an unused variable, so it might I might have to redefine it here. Let's see. Oh, no, it actually does, because the volatile means even though it's unused, it says absolutely declare it. So I'm going to step over here, and I'm going to look at what flag is. Flag should always be 0 if the command has been executed. So I executed that first start command, and the flag was 0. So that executed fine. So I'm going to step over, do another. Okay, that executed fine. That executed fine. Okay, do the late. Now we're going to send a start. That executed fine. That executed fine. So it looks like these are all executing just fine, but I'm not actually reading in any of the data here. Because I'm not getting any errors on it. I mean, I'm getting things here. I mean, that pressure is not at all correct, because, you know, I'm getting 0 here for for the pressure data and everything, because it's, which it's not 0. So those are definitely not correct here. So let me go here and double check, make sure that we did everything correctly. I said that the convert is 12. Let me double check the, yeah, 0x12, that's start pressure and temperature conversion. Okay, so that's correct. Let me make sure my pins are all connected correctly here. They are. Let's go back to, because it should just read this again. Yeah, because I put it in a loop. So I'm sending a restart, putting it in read mode. I'm reading a byte. But it reads 0 for that data. Then I read another byte, and it's still reading 0. All right, well, I'm going to pause this video so I can figure out where the error is and then start it back up again. Well, I've gone through here and looked at any possible errors that are going on here, and I've come to the conclusion here, because this pressure sensor I just found laying around in my house on one of my desks, and it was kind of under a stack of things and everything. So I think what I've come to is that my pressure sensor is actually kind of broken right now, and I only have the one at home. So I've double checked and rechecked my code here. This is all correct. This will give you the correct pressure. So I'd encourage you just to simply debug it on your own with it connected up and see if it works. And I'm going to try it again with a new device when I get with one of the ones on campus. And I'm going to just go through here and debug it one more time here to show you that I actually am getting something, but it's not correct here. Come on, what's going on here? Now I'm not even having it run even. What's going on here? So sometimes what happens with this, what you need to do, and it's what I'm doing right now, is I'm just turning the power off for my sensor, plugging it back in. Here. There we go. Because what happens sometimes if you're not careful, and I wasn't when you're debugging, if you don't, it can be like the bus can be in a start mode or something, and the device is saying, wait, you never sent a stop to me. I'm still waiting for data. And so then it's never going to operate properly. So what you do is you just kill the power to the sensor, and then you leave it off for a few seconds to make sure everything's powered down, and then you put the power back on, and it basically resets it. But if I go to the end of this here, hallelujah, I must have just reset it here, and it's now working just fine. Oh, isn't that frustrating? I'm sure you've all seen that before. But let's step through here, because I'm getting both pressure data and temperature data. I must have just had to reset the device. That can happen when, again, you don't have a proper stop command that's been entered. So what I want to do here is look at, okay, I'm going to compute this compensated pressure, and then I'm going to compute the pressure. And the pressure, this is 329.86, and that's in kilopascals. So let's go ahead and see what that is. in $329.86. Well, that doesn't seem right because that's saying it's 97. The atmospheric is 97.4 as atmospheric pressure, which is not correct in inches of mercury. It's about 30 millimeters of mercury right now. So I'm sure there's something funky going on with my pressure and temperature sensor because I'm not getting the correct readings here. So again, this is correct though as far as the process. The only other thing we could do is double check my formula to make sure my formula is correct here. But other than that, this is definitely, actually, my formula isn't correct, I think. I think I just missed something on the formula here. Or I think there's actually something missing. Where's the data sheet? Let me pull the data sheet back up. Not Arduino code. That was what I was doing to verify my thing, was to make sure that my code was correct, which it was. I remember what's going on here. I forgot this about the data sheet. So the formula actually here on page 6 is actually got an error in it, I believe. Okay. See, there's this 50 right here. If we go through here and look at kind of their example, if we go through, look at the example here, oh no, that does look correct there. Let's double check my code again here. Let's look at these P compensated here. Let's go back and run this again and step over this and see what I'm getting from my compensated pressure. $22,000. So there's something wrong in my formula here. There's got to be. Because if we go back here, this is again the lovely part of debugging here. Instead of, let's put these in decimal numbers here. Let's do a step over here. Oh my God, I'm a moron. All right. This is bit shifting them to the left 6 more. I need to bit shift them to the right, because I'm trying to get these zeros on the other side, and I just basically added 6 more zeros here is what I did. So I also got rid of a lot of information. Let's do this one more time here. So this now is correct here, this code here. Forgot to shift them in the correct direction. That's an idiotic thing to do. Let's see if it actually is going to work correctly here. Yeah, you see it's not running properly now, so I need to stop this. And what I need to do is I'm unplugging power from it for a few seconds. And then I'm going to plug it back in. And then I'm going to start the program back up here. Well, now it's being funky again here where it's not reading the pressure data, and I'm getting 0 for my pressure data. So yeah, my sensor's not working 100% correctly here, guys. Okay, there we get some pressure going there. Okay, now we're getting some pressure. Let's step over and see what we get here for my compensated pressure. 1316. Where's their compensation? Okay, so that looks like it could be reasonable as far as the number there. So let's see what my actual computed pressure is. 133.6. That's still too high. So there's definitely something going on with my pressure sensor here, and going on with the code in as far as my pressure sensor is not measuring properly here. But again, this code is correct with these two corrections that I had to make because I had bit shifted the wrong direction. And so let's look at the data sheet one more time to make sure, you know, we can actually even see here what the pressure of 410. So if I run this again, what I can even see is like, do these numbers when I get down to here, look at these as decimals. Yeah, the T data is way too big, but I haven't shifted it yet. So 495 for the T data, which seems correct. The P data is running low, so there's definitely something wrong with the pressure sensor on this, because the pressure sensor is reading too low. But it is actually now in a functional state.